Okay, guys, let's start chapter 7. Chapter 7 in chemistry is titled The Mole. And when you think about the mole, you might be thinking about a small burrowing animal, but in chemistry, a mole means something very different than an animal. So in chemistry, the mole is going to be a very important concept to understand. But in chemistry, a mole is a unit of measurement. So it's how we measure things in chemistry. Everything, every chemical that we measure out, we do it in terms of the number of moles of that chemical. And so it's a very important part of chemistry. And I think you're going to like this chapter. It's a little bit different than what we've done in the past. So there's a lot of calculating, and we're dealing with numbers. It's really a quantitative chemistry. And what I mean by that is quantity is a number. So we're putting a number to everything now. And so, for example, here's a question. It says, how many copper atoms are in 1 penny? And 1 penny has the mass of 2.5 grams. So if I asked you how many copper atoms are going to be in a penny, well, that's the kind of stuff you're going to be doing in this chapter. By the end of this chapter, you're going to be able to know that and be able to calculate how many copper atoms are in 1 penny. So I won't tell you right now, but by the end of this chapter, you should be able to calculate that. So, all right, let's get started. Before we get started, actually, I want to, if you're watching the video, make sure that you have a few things out. Number 1 is your Chapter 7 guided notes. You're going to be filling them out as we go through. Number 2 is the roadmap, which I'll go over in just a second, but I've given it out in class. I've given you a paper of which I call the roadmap. And the third thing I'd like you to have out is a calculator. Okay, we're going to be using a calculator every day in chapter 7 and 8, so please have that out. All right, chapter 7 guided notes start with the definition of a mole. So let me give you a second to write down the definition of a mole. It is the SI base unit used to measure the amount of a substance. So it's an SI base unit used to measure the amount of a substance. Well, just like the base unit for length, if we're measuring length in the metric system, is the meter. Well, in chemistry, when we measure some chemical out, so we have a pile of chemical, we're going to do that in terms of a mole. Okay, that's what a mole means. It's a base unit used to measure the amount of something. And the mole is abbreviated MOL. Yeah, I know it's just, you just don't write the E at the end of mole, but whenever you see MOL in the chemistry textbook, you know that's referring to a mole. So let's get a little bit better idea of what a mole is. A mole means a number. Just like 1 dozen equals a number, so does a mole equals a number. So what does 1 dozen equal? Well, 1 dozen is 12. Okay? 1 gross. I don't know if you know what a gross is, but a gross is a dozen. So 12 times 12, which would be 144. 1 ream means a number. A ream of paper. How many pieces of paper would you have if you had a ream of paper? Well, you would have 500. Well, 1 mole means a number. Okay, and let's talk about what that number is. 1 mole equals 6.02 times 10 to the 23rd. 6.02 times 10 to the 23rd. This is a very famous number in chemistry. Okay, very famous. And so if you have 1 mole of any chemical, you will have 6.02 times 10 to the 23rd particles. I wanted to talk about real briefly this number, 6.02 times 10 to the 23rd. And think about it. It's written in scientific notation. It's times 10 to the 23rd. So is this a large number or is this a small number? And hopefully you're thinking to yourself that this is a very large number. It's times 10 to the 23rd. So if we were to write that out, let me do that down here. So 6.02, and then we times it by 10 to the 23rd. That means we move the decimal 23 times to the right. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, and then we put a decimal. So let's just think about how big that is. That number is huge, but this would be the hundreds. Okay, this would be the thousands. This would be the millions. This would be the billions. Okay, this would be the quadrillion, or no, trillions. This would be the trillions. This would be the quadrillions. And after that, really, I don't even know. But anyway, suffice it to say, that's a huge number, 6.02 times 10 to the 23rd. The most famous number in chemistry. So 1 mole is equal to that number. Okay, and here's a little picture of a mole. That's an animal, but in chemistry, a mole means much different than that. Okay, so it's an SI base unit that measures the amount of something. It equals a number, which is 6.02 times 10 to the 23rd. All right, let's look at this a little bit more detail. So I said that 1 mole is equal to 6.02 times 10 to the 23rd particles. But in science, particle is a very generic term. It can mean a lot of different things. So when I say the word particle, it could mean atoms, it could mean molecules, it could mean compounds, or it might mean ions. So there's a lot of different things that particles can mean. And so yeah, it could mean atoms, molecules, compounds, or ions. So again, when I say the word particle, it could be any one of those. All right. Well, that number that we were just talking about, 6.02 times 10 to the 23rd, I said it was the most famous number in chemistry. In fact, it's given a name. Okay, this number is called Avogadro's number. Avogadro's number. So any chemist in the world, if you said Avogadro's number, they're going to say 6.02 times 10 to the 23rd. It's just something that you're going to memorize because we're going to use it so much in this chapter. Okay, it's called Avogadro's number in honor of this guy. Okay, his name is Amadeo. Whoops. Let's see if I can go back there. Okay, his name is Amadeo Avogadro. And he was an Italian chemist, and he worked a lot with chemicals in the gas phase. And he realized that if you have a gas of any element, that if you had 1 mole of that gas, it would contain 6.02 times 10 to the 23rd particles of that gas. And so he's the one that came up with this number, and so in his honor, we call it Avogadro's number. Okay. And again, it's a very large number, 6.02 times 10 to the 23rd. And we're going to be using this number a lot in this chapter and in the next chapter. So we have to learn how to put this number in our calculator. So I've got a picture of the calculator that we have. Okay, it's a TI-30. And so if you're using this calculator, I wanted to go over how to put this number into your calculator so that you don't make so many errors when you put it in. Okay? So when I put 6.02 times 10 to the 23rd particles, I don't know if you remember at the beginning of the year, I taught you this big E button. I call it the big E button. Okay? And what the big E button does, it's a shortcut. It means something. It means literally times 10 to the something. Okay, that's what E means. So when I put Avogadro's number in a calculator, I will put 6.02, then hit the big E button, and then all you have to do is hit 23. That's your exponent of 23. If you use the big E button, you will make a lot less errors. We don't have to use parentheses around it. You don't have to use the caret button, the times 10. You're going to make a lot less errors because the calculator, if you use the big E button, knows that you're talking about scientific notation, and it keeps this number all together. So you won't even need parentheses here. So I wanted to show you how you get to the big E button. I know it's a little blurry, but the big E button is this. It's found right there. And so what you have to do is you have to hit the second function, and then you have to hit this x to the minus 1 to get up to the big E. And so here's what you would have to put in your calculator to put in Avogadro's number. 6.02. Then if you hit the second function, and then hit the x to the minus 1 button, it will put in a big E for you. So 6.02 big E, and then all you have to do for the exponent is just write it. And so that equals 6.02 times 10 to the 23rd. Anyway, if you have problems using this big E button, come and talk to me. I will show you how to use this on your scientific calculator. But it's something that's going to simplify all your calculations, and you will make a lot less errors. All right, so let's get into some of the calculations and what this concept is about. I've got a picture here, and it's in your guided notes, so take a second and write down and fill out. So there's a couple circles. This circle is particles. Again, particles can mean atoms, ions, molecules, or compounds. This circle is for mass in grams. Okay, and then we've got this big rectangle over here, and that's for moles. And then in between moles and particles and moles and mass, I've got some arrows. This first arrow, and then there's a number here, okay, or a term. We times it by Avogadro's number over 1 mole if we're going to the left. If we go to the right, so from particles to moles, we times our number by 1 mole over Avogadro's number. So you'll notice if you go one way compared to the other way, all you do is switch this term right here that you times it by. This is called a conversion factor. This is a conversion factor. Notice how they're related. If you go to the left, Avogadro's number's on top. If you go to the right, Avogadro's number's on bottom. Okay, and again on the bottom, if we go from moles to mass, we have a conversion factor. If we go from mass to moles, we have another conversion factor. So what I call this paper, and I pass it out in class, but I call this paper the roadmap. And that's exactly what it is. It's a map. And as long as you know where you're currently at, a map will show you how to get to your destination. It kind of maps out how you should get there. And it makes these calculations very easy if you will follow the roadmap. So I'm going to be talking a lot about the roadmap, but this is the paper, or this is the diagram that I want you to be looking at. Okay. So real simply, what is the roadmap? Well, it's a way of converting units. We can go from moles to particles by timesing it by this conversion factor. We can go from particles to moles by timesing it by this conversion factor. We can take something in terms of moles and go to grams by timesing it by this conversion factor. And if we have grams currently and we want to go to the number of moles, we times it by this bottom one. Anyway, I'm going to show you how to use the roadmap, but that's what I'm talking about. It's just a way to make these calculations a bit easier. What we're going to focus on today is this top part, going from moles to particles. So if we're going from moles to particles, we take this top bridge across. Or we might go from particles and go over to moles and cross this bottom bridge. Okay. So we're going to focus on those types of chemistry problems today, moles to particle conversions. So I might give you a question that says, if you had 5 moles of a chemical, how many atoms would that be? Well, you would take 5 moles and times it by this conversion factor here. Or I might say, if you have Avogadro's number of atoms, how many moles would that be? And you would times it by this conversion factor. So, all right, let's get started and you'll see what I mean. Okay. For this first part, we're going to be converting from moles to particles. So we're going to use this conversion factor. 1 mole is equal to Avogadro's number of particles. But before we do that, I wanted to talk about what a conversion factor is. If you remember at the beginning of this year, I started by talking about conversion factors. Okay, and I gave you a lot of examples. But conversion factors mean the same value, they just switch the units. So let me give you some examples. I think it will come back to you. If we say 1 year is equal to, what's another value that means the same time as 1 year? Well, it's 365 days. Is it the same time? 1 year, is it equal to 365? Yes. All we're doing is converting units from years to days. There's a lot of different conversion factors out there. Let's talk about another one. What if I said, let's do something other than time. Let's say 12 inches is equal. Now let's convert that to another unit. Let's go to feet. Okay. And 12 inches, and you guys know this, is 1 foot. Well, is it the same value in terms of length? 12 inches is equal to 1 foot. All we're doing when we're using conversion factors is switching units from inches to feet or from years to days. We're going to be using this conversion factor, which goes from moles to particles. Okay. All right, let's get started. For practice problem number 1, I want to go through this one slowly, and I want to go through a number of steps that I use. And I still use these steps today, and I've done thousands of these problems. So please, as you're learning these, I want you to use these 3 steps. Step 1 is we're going to read the problem and do some things with it. It says, how many molecules of water are in 2.5 moles of water? So what I always like to do in step 1 is underline what they gave us. They're telling us we have 2.5 moles of water. That's what they gave us. And I want to circle what it is they want us to go to. We're supposed to calculate how many molecules of water that is. Okay? And so that's step 1. I underline what they give us, the number that they give us, and the units as well. And then circle what units they want us to go to. Okay. Step 2, always write down what they gave us, so 2.5 moles of H2O. And put it over 1. Now notice something here, guys. I didn't just write 2.5 and put it over 1. You've got to say the units. What is it that you're talking about? 2.5 what? It's 2.5 moles. And also, what substance are we talking about? In this example, it's water. Okay, this is always going to change. I don't know what the next problem might not be about water. But this one is, so it's 2.5 moles of water. You've got to have the units here. It'd be like somebody saying, I have 1 million. Well, you might be thinking, 1 million what? Is it 1 million pieces of garbage, or is it $1 million? It makes a huge difference. So always include what you're talking about. You have to communicate what you have 2.5 of. It's 2.5 moles of water. And we get that from the problem, and that's why we underline what they gave us. Okay? So step 1, underline what they gave us, circle what you're supposed to go to. Step 2, put down what they gave you over 1 and put it in parentheses. Okay, step 3, I like to go to the roadmap. Okay, I've got a small diagram of the roadmap here. If you're watching the video, you might not be able to see it clearly, but you have a roadmap of your own, so you should have it out and be looking at it. Okay, so we're going to look at the roadmap on step 3 and decide where we're at. Okay, well, whatever you underline what they gave us, that's where you're currently at. We're at 2.5 moles of water. So let's go to the moles box, and that's where we're at on the map right now. Okay, we want to determine where this problem wants us to go. It wants us to convert that moles to molecules. And you see molecules on the roadmap right here. It's a particle. So I'm going to put a little star there. That's where we want to go. That's our destination. Okay, so now we have to use the map. Let's map out a path to get there. We're going to go across this top bridge because that arrow is pointing to the left, and that will get us to where we need to go. So what that means is we're going to times our number by this term, this conversion factor on top, which says we're going to times it by Avogadro's number on top divided by 1 mole. Okay? So let's make a new conversion factor here. And you just look at the roadmap. It says Avogadro's number goes on top, and 1 mole of the substance goes on bottom. Now, I didn't tell you in the roadmap what the substance was, because the problem could change every time. This problem is about water. So if moles of water is up top, we know that down here you've got to have moles of water. In 1 mole of water, there's Avogadro's number of molecules of water. So let's put that. Molecules of H2O. Okay? So remember, always have a number, but always have a unit and a substance. Okay? There's a number of things you need to put in here. Well, okay, now what this essentially did by putting our conversion factor in this way was allow us to cancel out a unit. We're going from one unit to another unit. And so if you look at this, what's moles of water divided by moles of water? So anything like 5 divided by 5 is equal to 1. You can cancel those out and it just equals 1. Well, any number divided by itself is 1. Well, any units divided by itself is also going to cancel out. So moles of water divided by moles of water, I want to see you cross that out. Just strike that out. Now be careful, you can't cross out the numbers, but the units will cancel out. And so whatever you start out with better go on the bottom of the next conversion factor. What you want to go to will end up on the top of that conversion factor. So what we did by setting our problem up this way was we've gone from moles of water to molecules of water. And since we are to where we wanted to go to molecules of water, and that's where we're at, I'm just going to throw on an equal sign and be done. Okay, now it's a math problem. So you take 2.5, times it by Avogadro's number, and that number goes on top. So let's grab a calculator and do that. Okay, so 2.5 times 6.02, use the big E button to the 23rd. And I get 1.505, so I'm just going to round that up to 2 decimal places. So 1.51 times 10, so I'm just going to put in a big E here, to the 24th. Okay, that's our number on top. And then to get the number on the bottom, you just times all the bottom ones together. 1 times 1 is 1. And anything divided by 1 is itself, so that answer is 1.51 times 10 to the 24th. Now, if you were to just circle this, I would mark it wrong. Because you've got to communicate to people what you have 1.51 times 10 to the 24th of. What is it? Well, the answer is always going to be found at the top here, and it's molecules of water. Molecules of water. Okay, so always, your answer contains a number, and it better contain some units here, and a substance of what you're talking about. Okay, so let's take a second and look at what we just did. We started with, it said we had 2.5 moles of water. So in 2.5 moles of water, we have 1.51 times 10 to the 24th molecules of water. So all we did was convert from moles to molecules. And that's what the roadmap helps us do. Okay, let's look at another one. I want to go through a number of these problems, and hopefully by the time we're done, you'll have a pretty good feel of how to do these problems. So let's go to, let's see, we did get that one right. 1.51 times 10 to the 24th. Molecules of water. All right, practice problem number 2. Okay, let's remember those steps. There's 3 steps. Step 1, let's read it and underline what they give us, circle what we're supposed to find. So it says, determine the number of zinc atoms in 4.5 moles of zinc. So step 1, let's underline what they gave us. What's the number that they gave us? Well, it's 4.5. 4.5 moles of zinc. Zein is zinc. Now let's circle what it is they want us to convert that to. They want the number of zinc atoms. So I'm going to circle zinc atoms. Okay, that's step 1. Step 2, we're going to write down what they gave us. 4.5, always include the units, moles of zinc. I'm going to abbreviate zinc by putting its symbol. Over 1, always put it over 1 because that will help us line it up as we add our conversion factors. Okay, that's step number 2. We put down what they gave us over 1. Step 3, let's go to the roadmap. Okay, the roadmap down here. Let's find out where we're at right now. It said we had 4.5 moles, so that's where we're at. Okay, we're here. And we want to go to zinc atoms. Where do you see atoms on this roadmap? Well, it's right here. It's a particle. So again, we're going to have to go over to the particles circle. How do we get there? I can't take this bridge across because it's pointing to the right. I need to go across the bridge that points in the direction we want to go. So again, we're going to be using this conversion factor. See how easy the roadmap makes this problem? So let's add that conversion factor in right here. It says Avogadro's number on top, so I'm going to put that here. And it's got 1 mole on the bottom, so I'm going to write 1 mole on the bottom. Now again, I didn't include on the roadmap what the substance was here, but we know that it's moles of zinc. So if moles of zinc is right here, we're still talking about 1 mole of zinc down here. Now, I didn't include on the roadmap what you have Avogadro's number of, and that's because every problem is a little different. But we're trying to convert to zinc atoms. So we got Avogadro's number of zinc atoms. Okay. So that goes there. Always remember to fill in your units there. Now, it looks like my moles of zinc and my moles of zinc are going to cancel out. So I'm going to strike through those units. I'd like to see you guys do that as well. We're left with zinc atoms. Well, guess what? Zinc atoms is what we were trying to go to. So I'm going to finish the problem, throw on an equal sign, and now it's just a math problem. We take 4.5, times it by Avogadro's number. That goes on top. Okay, let's do that now. So 4.5 times 6.02 e to the 23rd. And I'm getting this number 2.7, if we round to 1 decimal, 2.71 times 10 to the 24th. Okay, and then you take all the numbers on bottom. 1 times 1 is, again, it's just 1. And so anything divided by 1 is itself, so that one's easy. 2.71 times 10 to the 24th. Now, can I just circle that number and be done? The answer is no. You will get it wrong if you don't include units. Well, you might be saying, what are my units? Well, always, if you forget, it's always going to be the last, your units on the last conversion factor on top. Okay, so this right here will always go to your units. So it's atoms of zinc or zinc atoms, same thing. Okay. So if you had 4.5 moles of zinc, that would equal 2.71 times 10 to the 24th atoms of zinc. So all we did was convert from moles to atoms. Okay, practice problem number 3. Let's try this one. How about you guys try this one on your own? Okay, there's 3 steps. Remember to underline what they gave you, circle what you're trying to go to. That's step 1. Step 2, write down what they gave you over 1. And step 3 is to use the roadmap to figure out what your conversion factor is. You got to times it by. Anyway, try that. If you're watching the video, please hit pause, try it first, and then once you have an answer, hit play and see if you got it right. Okay, let's see how you did. Hopefully, you underlined 11.5 moles of water, and you're circling. It looks like it wants us to go to molecules. Okay, so that's what we need to go to. Okay, that's step 1. Step 2 is to write down what they gave you, 11.5 moles of water. So again, include not just the number, but the units and the substance that you're talking about. Put it over 1. That will help us line up our problem going forward. Okay, that's step 2. Step 3 was to use the roadmap down here. Where are we right now? Well, it gave us moles. So we're right here. Okay. we want it to go to molecules. Where do you see molecules on the roadmap? Well, it's right here. Okay, so to get there, we're going to cross that bridge that's going that direction, and that looks like we better times it by that conversion factor. So I'm going to make that conversion factor here. It wants us to put Avogadro's number on top. And 1 mole on the bottom. And again, I don't put the units on the roadmap because I don't know exactly what substance you're going to be talking about, but we're talking about water on this problem. So moles of water is on top. We know that it's got to be moles of water on the bottom. Well, what are my units on the top? I've got Avogadro's number of what? Well, we want to go to molecules. So let's put that. Well, molecules of what? The substance that we're talking about in this problem is water. So I'm going to put molecules of water in that top one. And now since my units are 2 molecules of water and that's what I needed, I'm going to stop. I'm going to throw in an equal sign. And now it's just a math problem. Let's take 11.5 and times it by Avogadro's number. So 11.5 times 6.02, big E to the 23rd. And I'm getting this number, 6.92 times 10 to the 24th. Okay, let's take the bottom numbers. 1 times 1 is just 1, so I'm just going to leave it there. I mean, you could divide it by 1, but that equals itself. 6.92 times 10 to the 24th. Now, if you circled that, even though your number is correct, I'm going to mark it wrong because you've got to include what you're talking about, your units. Okay, and again, let's go back to our units over here. Moles of water divided by moles of water is 1, so we cancel those out. That leaves us with the units of molecules of water, so that's what we're going to put here. Molecules of H2O. Okay. And there's our answer. So hopefully that's what you came up with when you were solving the problem. All right, I've got another problem here, but it's a challenge problem. I would like to go through this one with you because there is a little twist to it. So let's read it. It says, calculate the number of oxygen atoms in 5 moles of oxygen molecules. And it says that oxygen is a diatomic molecule, which is O2. Okay, let's use the same 3 steps. Okay, let's underline what they gave us. The only number that they gave us is 5. Well, 5 moles of oxygen molecules, and we know the oxygen molecule is O2. Okay, now let's circle what they want us to find. What is it that they want us to find? And it says calculate the number of oxygen atoms. So I'm going to circle oxygen atoms. All right, that's step 1. Step 2, let's write down what they gave us, which we underlined, 5 moles. And I'm going to put O2 for oxygen molecules. And let's put that over 1. Okay? So that's what they gave us. That's step 2. Now step 3, let's go to the roadmap down here. Okay, and let's figure out where we're at. If they gave us 5 moles, we've got to be in the moles box over here. So again, we're right there. And what is it that we want to go to? We want to go to oxygen atoms. Well, atoms is right here. Okay, and so we're going to have to take that top bridge across again. So this is our conversion factor that we're going to times it by. So let's do that now. Put in that conversion factor here. And it says Avogadro's number is on top, 6.02 times 10 to the 23rd. And 1 mole goes on the bottom. Now again, I didn't put what the units were on the roadmap because it can change in every problem. That's why it's so crucial that you look back up here with what we started with. That's got to go on the bottom of your next one. So 1 mole of O2 molecules. Now, what makes this a challenge problem is that we can't go directly from molecules. I couldn't put Avogadro's number of atoms here. So in 1 mole of oxygen molecules, we have 6.02 times 10 to the 23rd oxygen molecules. So O2 molecules goes here. So my moles cancel out here. And now I'm left with oxygen molecules. And so what made this a challenge problem is I can't stop there because this is a molecule. There's a difference between O2 and just oxygen atoms. So let me ask you this question. How many oxygen atoms are there in one oxygen molecule? And you see this little subscript 2, that tells us there's 2 oxygen atoms here. So I'm going to make a new conversion factor using that, where I go from molecules to atoms. So again, I've got O2 molecules on top. I need O2 molecules on the bottom. Well, in one O2 molecule, there are 2 oxygen atoms. Okay. And so my oxygen molecules divided by oxygen molecules will cancel out. And now my units at the top, right here, are exactly what we were trying to find earlier. So this was a challenge problem in that you had to create your own conversion factor and to get from molecules of O2 to atoms of O2. And so now that my units here align with what I was supposed to go to, I can throw on an equal sign, and now it's just a math problem. So let's do 5 times Avogadro's number times 2, and put that number on top, right here. And so that's 6.02 times e to the 24th, because it's essentially just 10 times this, which another 0. 10, so 6.02 times 10 to the 24th. And now let's take the numbers on bottom. 1 times 1 times 1 is 1. So I've got 6.02 times 10 to the 24th. Now what are my units? Again, look back here at the top. It's going to be oxygen atoms, or atoms of oxygen. Okay, and there's my number, and I'm including the units and the substance. So that's good. That's a challenge problem. We'll get to the point where you can solve those very easily. So, okay, good job. Now we're going to switch gears a little bit. We're going to convert from particles to moles. So what we're going to do is go from this circle, and we're going to go to moles over here. Okay, so we're here now, and we're going to go across this bottom bridge and go to moles. So the conversion factor that we're going to use is 1 mole over Avogadro's number on the bottom. So notice, if we switch directions on the road map, we just flip the conversion factors. So now 1 mole goes on top and Avogadro's number goes on the bottom. So it does matter which direction you're going. You would always want to use your road map to make sure you've got the correct conversion factor. Okay, but again, the same process. So let's read it. How many moles of water would you have if you had 2.11 times 10 to the 24th water molecules? Let's underline what they gave us and just look for a number, because, I mean, where else can we start? We have to start with this number and include the units. Now, what is it that they want us to solve for? Well, it said how many moles of water. So I'm going to try to convert to moles of water. So circle that. Okay, step 2. Write down what you underline and put it over 1. So 2.11 times 10 to the 24th water molecules, or molecules of H2O, and put it over 1. Okay. Step 3, now let's go to the road map. Let's look at where we're at now. Now we're at molecules of H2O. So where do you see molecules? Well, it's right here. So I'm going to draw, that's where we're currently at. Now let's decide where they want us to go to, and it's moles of water. So they want us to come down here to moles. So which bridge do I cross? Well, I cross this bottom bridge, and I'm going to use this top conversion, or the bottom conversion factor this time. So 1 mole over Avogadro's number. So let me put that in. 1 mole goes on top, and now Avogadro's number goes on bottom. Okay. Again, it didn't tell me, I didn't include the units for your roadmap because it changes every problem. But if molecules of H2O is on top, we know that it's got to go on the bottom of your next one. molecules of H2O go here? Well, we're talking about that number of molecules of H2O. Well, in 1 mole of H2O, there's that many molecules of H2O. Okay. Now let's look at it. My molecules of H2O is going to cancel out. Molecules of H2O divided by molecules of H2O is 1. And we're left with the units moles of water. Well, guys, look, that's what we wanted to go to. So I'm done. I'm going to throw in an equal sign. And now it's just a math problem. This number times this number goes on top. Well, it's still going to be 2.11 times 10 to the 24th on top. 1 times Avogadro's number goes on the bottom, so 6.02 times 10 to the 23rd. Okay, so let's grab a calculator and let's divide those two numbers now. So 2.11 e to the 24th divided by Avogadro's number. And I'm getting this number, so 3.50. 3.50 what though? Hopefully you're including the units by now. If you don't remember what units were, go to the top of your last conversion factor and that's what it's going to be. So this is going to be moles of water. Okay, so let's look at what we just did. They gave us a whole bunch of water molecules and they asked us how many moles that would be. So all we did was cross the road map. Here's the conversion factor. We times it by, and if you did it right, that many, this huge number right here of water molecules equals 3.5 moles of water. Let's continue on. Practice problem number 6. I want you guys to try this one on your own. Again, if you're watching the video, please hit pause, try it. Try to go through all 3 of those steps and get an answer and circle it. Once you have that answer, then hit play and see if you got it right. Okay, let's see how you did. I went ahead and did step 1 and 2 and 3, and so hopefully on your paper looks like mine right here. So I wanted to pick it up from this point. So you underline what they gave you. You circled the units that we're supposed to go to. You put down what you underlined over 1. You went to the road map. You were at atoms. You want to go to moles. So we're going to times it by this conversion factor. So we put 1 mole on top, Avogadro's number on the bottom. We know that we're talking about atoms of zinc, so that's got to go down on the next conversion here. And this many atoms of zinc equals 1 mole of the substance that we're talking about in this problem is zinc. Okay, now when you get to this point, our moles of zinc, we can stop because now we're at moles of zinc and our units here are at moles of zinc. Our atoms of zinc divided by atoms of zinc cancel out. And so now it's just a math problem. We've got this number times 1, which is itself, so 4.5 times 10 to the 24th divided by, what's 1 times Avogadro's number? Well, it's 6.02 times 10 to the 23rd. Okay, when you put that in your calculator, you should get 7.48 if you round it to 2 decimal places. And that's the number, but what are our units? Okay, again, come back here. We're talking about now moles of zinc. Okay, very good. Hopefully you understood and can follow me through these problems by now. I got another one here. So let's try practice problem number 7. Again, I want you guys to try it on your own. I think there's so much use, so much value in you trying it on your own first. So go through those steps, try it. Once you get an answer, hit play and see if we got it right. Okay, let's see how you did. I went ahead and solved the problem. So hopefully your paper looks like mine at this point. So you underline what they gave us. Again, look for the number and the units. So 5.75 times 10 to the 24th atoms of aluminum. And it wanted you to convert it to moles of aluminum. So you circled that. Step 2, hopefully you put what they gave you, put it over 1. Step 3, hopefully you went to the roadmap. We're at atoms because that's what it gave us. So atoms is right here. And it wanted you to go to moles of aluminum, so we circled that. So we're going to have to come over to moles. We're going to times it by this conversion factor. So I put that conversion factor here. If we had atoms of aluminum on top, that's got to go on bottom. And we're talking about 1 mole of aluminum. So I put that on top. Okay, when this unit on the top becomes what you wanted it to be, that's when you stop, throw in an equal sign. Then it's a math problem. Times across the top, times across the bottom, and then divide in the end. You should have got 9.55 moles of aluminum for the answer there. All right, I've got one more practice problem, and I'm going to go through this one with you, okay? Not that it's hard, so if you want to pause the video and try it on your own, you can do that. But I'm going to explain it again one last time here. Okay, let's read it. How many moles of CO2 are there if you have 3.75 times 10 to the 24th molecules of CO2? Okay, step 1. We find out what they're giving us. Always look for the number and then include the units. That's what they're giving us. We want to decide what they're asking us to go to, and it says how many moles of that. So moles of CO2 is what they're asking us to find. Okay, let's go to step 2. We write down what they gave us and put it over 1. So 3.75 times 10 to the 24th, and include the units, molecules of CO2. Okay, we put that over 1. That helps us align our conversion factor and our math problem up. All right, that's step 2. Step 3 is to come down to the roadmap now, and let's look at where we're at. We started with molecules of CO2 because that's what they gave us. So where do you see molecules? We see it right there. So we know we're in the particle circle here. And now we got to decide where we're going. Well, we want to convert to moles of CO2. Well, moles is over here, so I'm going to draw a little star. That's where we want to go. So let's map this out. The only way that this guy can get there is by coming across this bridge on the bottom. So we've got to times our number by that conversion factor there. So let's do that. So we make a new conversion factor and put 1 mole on the top and Avogadro's number on the bottom. Again, I don't include the units on the roadmap because every problem's different, but what you can do is always look at what you started with. If molecules of CO2 is on top, we know that it goes on the bottom. Whoops, that's CO2. Molecules of CO2 on the bottom. So there's Avogadro's number of molecules of CO2 in 1 mole of the substance that we're talking about, is CO2. All right, now I know that my molecules of CO2 units are gone because they're dividing by themselves, so they cancel out. And we're left with this unit, moles of CO2. When this unit on the top matches what you were asked to go to, then you can stop, throw on an equal sign. Now it's a math problem. So this number times 1 is that number, so 3.75 times 10 to the 24th goes on top. And to get the bottom number, you just cross multiply across the bottom. So 1 times Avogadro's number is Avogadro's number, so we put that on the bottom. Now put it in your calculator and divide those two numbers. So 3.75 times 10 to the 24th divided by Avogadro's number. And I'm getting this number, 6.23. If you round it to 2 decimal places, it's 6.23. And what's my units going to be? Well, the only units that we have, the other ones canceled out. The only ones that we're left with is moles of CO2. So that is our answer. So guys, hopefully that made sense what we're doing here. It's going to set up this whole chapter. You've got to understand this video. If you didn't, go over it again. Watch it a couple times. But yeah, the rest of the chapter and the next chapter for that matter, we've got to know how to do this stuff. So It's a little different. We're talking about quantitative chemistry now, where it's not good enough for a chemist to just say, go get a pile of chemical A and mix it with a small pile of chemical B. We want to be exact with our numbers, and that's what we're going to get to. We're going to be very exact with our numbers and measurements. And so it's a very precise science. And we're just learning the foundation of it right here. So please make sure that you understand this video. Hey, now that you know how to do this skill, I wanted to give you some more practice. So please go to your student workbook. There's a worksheet. It's titled Mole to Particle Conversion Worksheet. Again, it's titled Mole to Particle Conversion Worksheet. Go there now and try a few more on your own. Get comfortable with this process. There's 3 steps. Remember, underline what they gave you in the problem. Circle what they want us to find. Step 2, put what they gave you over 1. Step 3, come to the roadmap and figure out your conversion factor. Write it in, and it's just a math problem after that. So hopefully that's pretty easy, and it's starting to make a bit more sense. But yeah, hopefully this video helped.